All right, I think we can start. Thank you, at least for attending my workshop. I hope you get something out of it. It will be in two pieces. So first I will explain why we want to add observability to our software systems. And secondly, if you still want, it's up to you. I will take you through a complete setup, all right, with some APIs, with a messaging system and some workers, and then see if we can get observability working from the front until the back, all right? It will be done in .NET though, because I'm a .NET developer, but the tools are also available for Java or anything else. But like I said, it's up to you. If you want to follow the workshop, fine, you can stay and then follow along. And if not, after the presentation, you can also leave if you want to. It's up to you, okay? But first things first, let's get through the why. Why are we going to do this? Maybe first something about me. I'm Glenn. I work for an insurance company in Belgium called Baloise. It's actually Swiss, but yeah, I work in Belgium. I'm currently there as a system expert. That's the name they're giving us, but that's actually a fancy title for a software architect. And you can find me still on X or Twitter, what's it called today? Or a Mastodon if you want to reach out. I think I'll keep standing here because I forgot my clicker. So one of the first things that you maybe encounter when you're working with a distributed software system, so probably most of the people here are working with some kind of distributed system. Even a monolith can be distributed between several systems or microservices. Well, it should be nice if you would have some distributed tracing. So tracing means that we can see what happens. Okay? We want to observe how some requests went through our system. Okay? So from the front end, or maybe from a batch job, or for a cron job, or anything else. So at a certain point, there will be a request on your software system, and you want to be able to trace that call throughout your software environment. So that's the whole idea about observability, okay? And to do this, we have several tools available, and we will pick one during this demo. It's going to be OpenTelemetry, because I think that's a fancy tool, and it's open source, and everybody loves it, so that's amazing. So that's the definition of distributed tracing. But why is it now important? Well, because you have a system that doesn't have the distributed tracing or a system that has the distributed tracing, all right? So here on the left-hand side, if something happens in your software environment, and maybe a typical large company like mine will have 6, 7 different development teams working on different parts of the software system as a whole, well, if one of the teams finds a bug, good luck talking to the other team saying, yeah, it happened at that time, maybe it was that kind of request, we had that payload. You don't have a common communication way between those teams, maybe. If you have, great, then you're already a step forward, but it could be you don't have such a thing. It could also be that teams are located around the world, and then maybe in your log file it said, okay, at 1:30 we had a call, and then the other guys need to go trace their logs and see, oh no, we're 5 hours behind. We need to see that the log files are correct, or that we match the same trace, okay? So that's also annoying, of course, and that's not what you want to do, okay? So in the ideal world, and I hope at the end of this workshop we'll have this picture, there's at a certain point a call coming into your, a request coming into your software environment, and the request goes through several parts of your software environment, and you can actually, with the tools that we're going to use, follow along where it happened, okay? And what it did and why did it do that part, okay? And even better, and we will see that later on, it doesn't matter now anymore where in that trace, we call that a trace, you pick the information. So if you pick the information even at the almost last step, you can trace it back. That's the whole idea of having distributed tracing and observability in your system. So that's the important part, all right? Now, how does this work? Well, actually, the principle is very easy. As soon as your first interaction with your software system happens, you'll check if there is an identifier in the HTTP header. If it's not there, you generate one, a unique reference, and you add it. As soon as the request hops to another system, you pass along that identifier, and in the other system, the same thing happens. It will see, oh, there is already a tag. Okay, fine. I'll grab it, I'll put my tag beneath it, and pass it along. So you create a chain of identifiers, and there will be one identifier at the top, calling the trace ID for the whole set, and then each element will have its own ID, knowing where you were in the software evolution, all right? But doing that is hard. And so the principle is nice and it's very easy, but doing it is actually not that, it's not that hard, but still you have to acknowledge some certain playground for all the development teams. Well, if you use an open source framework like OpenTelemetry, it will take care of everything for you. So that's the main benefit why we're going to pick OpenTelemetry, all right? You don't need to take care of this on your own. It will do it for you, okay? Now, what is OpenTelemetry? Well, like I already said, it's an open source project. It's a set of APIs and SDKs. It has tooling, it has integration, a whole bunch. But in the end, it will leverage traces, metrics, and logs. So what's the difference a little bit here? Logs, that's probably you know already. It's just logging what you want. Anything that you want to write to a disk or in memory, or doesn't matter, or in a database. You just log what you want because it's maybe good information for later to gather or to look at. Then we have metrics. Metrics is collecting like how many memory usage is happening or is being kept during your process. Are my hard disks still performing well? How many megabytes do they still have left? Stuff like that, so metrics. And then we have the traces, and that's what I already covered. The traces are just what's the flow of your requests during your system, okay? So those three things will make up the observability that we are going to cover during this workshop, and we're all going to do this with OpenTelemetry, all right? Now, I already explained this a little bit, but let's get through it one more time. So we have a trace, and it will have a root span. So the root span is the identifier I talked about. So it's the first thing that when a request comes into your system that will be created, and then at each hop, another span ID will be added. But you keep the root span as saying that's the complete trace, and then each system will have its own span ID. But visually, that looks a little bit like this, and maybe that makes it a lot easier to follow. So at a certain point, a customer is at your website. You have a front end, and he clicks on a button, like we've seen this morning with a cart, or you want to order something. It doesn't matter what it is, but there's an action being done on the front end. Well, that's the first action we'll make. Our root span, so the first identifier, okay? And as soon if it goes to another element in your system, so maybe to one API, and that API calls another API, and that API calls a database, well, each time during the hop, another span identifier is created and added to the chain. And in the end, when you come back, you will know from which point the request came in, where it went through, and even so, because on each hop, the identifiers and some metadata is passed, you also know how long it took during that process. So how long API A took its time to process, how long API B took its time to process, and even how long the database gave you a response back, okay? Now, like I already mentioned, you could do this on your own. You can write this software by yourself if you want to, but in the end, there were some pretty clever people around, and they created a framework for this, the OpenTelemetry framework. It's open source, and a lot of big companies went for it. So Microsoft, the .NET ecosystem, completely integrated it. It's even now possible to have instrumentation in Azure by default in the OpenTelemetry framework. So that's amazing. But there are almost for each technology, there is an SDK or an API available that you can use. So don't stick to .NET. You can pick any others if you want. I will show you later on the website of OpenTelemetry where you can find which ones are available. Oh yeah, and there are two things that you need to know depending on which level that the technology stack is at. You will either have automatic instrumentation or manual instrumentation. So the difference is that for the automatic instrumentation, the framework will do everything for you. So you only need to do some configuration and you will have all the benefits. With the manual instrumentation, that means that the development team is not yet up to speed, and then you have to put in some code, lines of codes extra to get the benefit of OpenTelemetry, but they're minimal, and it's just to get the flow going, all right? So it depends a little bit on the tech stack if you get the automatic instrumentation or you have to do some coding yourself, all right? That's why I picked .NET, because we only need to configure things and we don't need to write code for OpenTelemetry, so that's also a benefit. But for Java, it's also with auto instrumentation, all right? Now, if you go for OpenTelemetry, it is possible to send all the information, so the logs, the traces, and the metrics, to a certain backend. So you have different backend systems available to get visual views and dashboarding on that information. But it's even, oh, I lost the micro, no, it's back. It's even better to put a middleman in between, and it's called the OpenTelemetry collector. There are several benefits on why. Maybe I will talk about, I think the cable is just a little bit too short and my pants are, so maybe put it like this. Yeah. So the OpenTelemetry collector has some benefits. One of them is that you can plug in some different processors. So if you want to do some data manipulation while the data is flowing through to your backends, so the data meaning the logs, the traces, or the metrics, then the OpenTelemetry collector can help you on manipulate that data if needed or do some stuff with it, all right? And we typically do that with processors. But the OpenTelemetry also needs to receive the data, and that is done with receivers, and it can export the data again, and that's with exporters. So the OpenTelemetry collector is just a gateway, and it's just, you have to view it. I will show it visually a little bit like this. So your data is coming from your software system. It will go through the OpenTelemetry collector and it will go back to some backend system, okay? So the OpenTelemetry collector is just software that you deploy somewhere as a middleman, okay? But like I told you, the benefits are because you can do some processing on it if needed, but the other benefit, and now visually that will be very clear to you, if you already have some observability stack in place at your current company, maybe you already know Jaeger or already know Prometheus, or on the other side, you already have some other tools available to do some dashboarding or anything. Well, the OpenTelemetry collector has plugins for most of the common used current observability stacks. So even though you currently are not using OpenTelemetry protocol to process your data, you can still use the OpenTelemetry collector to convert it to OpenTelemetry protocol if you want to, but it's also up to you. So even with this in place, you don't have to adjust your software system if you don't want to, but you can get benefits already by using the OpenTelemetry collector. So it can change the protocol of the data. Like I said, it could be that you have some Prometheus data endpoints available. You pull them in OpenTelemetry collector and you can push them out in an OpenTelemetry protocol through another system that understands OpenTelemetry itself. One of the things that we are going to use during the workshop will be Grafana. So in our ecosystem, Grafana is the thing that I chose to do the dashboarding and to have the visual setup, and it understands OpenTelemetry out of the box, the protocol, so you can use an OpenTelemetry collector in combination with Grafana, all right? Maybe a little bit too abstract, but like I said, after the demo, you will understand how this works and why this is very nice to have in your environment. Maybe another benefit that you can do, like I said, there are those processors. Well, what you can do is also filter out data that you don't want to have if you don't need it, all right? Could be that you have some, I don't know, an IoT system with sensor data, and it pulls in sensor data maybe each 2 seconds. Are there maybe already some questions about OpenTelemetry and observability in general? Because like I said, I rushed maybe a little bit because we only have a certain amount of time to do the workshop, but if there are any questions already?
If you compare that with Datadog, for example, what's the advantage or disadvantage of this open source?
Yeah, that's actually it. Yeah. I just like the fact that because it's open source and a lot of the big companies are visiting it, I think it will have more growth. But like I said, there are also third-party tools that just do the same thing. Yeah.
What you're saying that with these, you can do exactly the same with Datadog?
Yeah.
Same features?
I don't know each third party to make it. But one of the main advantages why OpenTelemetry becomes so popular is because of this, is that if you already have something in place and you want to start with a new project, you can plug it in and you can divert the other ones without touching them. So that's one of the benefits for that. But for sure, if you already invested in a third-party tool and are doing enough with all the software teams, then probably you don't need anything that I'm telling you today.
Yeah. And that is one of the best, so you don't need to look outside.
Probably not. But yeah, that's the only thing.
This is last observability.
Yeah.
So it's cheaper.
Okay. But yeah, those tools are around already for a long time, and they touch on a lot of those same things. And probably we'll have some more tooling available than OpenTelemetry, but OpenTelemetry is indeed open source and cheap because you can host it yourself if you want to, but yeah, then you have to pay your hosting, of course. You can also do it as a SaaS environment if you want to. But yeah. So this is the workshop. All right. What do we need? Well, at least we're going to need some editor. So I'm going to use Visual Studio Code for this because that's my go-to tool. And the other thing that you need is just a laptop where we can install Docker and .NET. All right. So normally, if you scan the QR code, I hope it's big enough. I'll make it. It's not readable anymore. If you scan the QR code, you will be on this page. So this is just the complete workshop, like I said, is the gist. And it goes through all the steps that you can do and to get the demo up and running. All right? It consists out of different labs. First, we're going to set up the environment. Then we'll add some monitoring because that's actually the first thing that you normally should do in a production environment. At least monitor if your APIs are up and running and are performing like you would. Then we're going to add alerting, or maybe we're going to do that at the end. I don't know, maybe skip alerting a little bit, but that's also an important part. I didn't talk about that during the slides, but of course, if you have monitoring, it's easy to set it up. But if you don't look at monitoring, then you're not going to gain anything. So at least set up some alerting that if something goes wrong, somebody gets a notification, right? Well, with the Grafana tool stack, it's built in. You just have to configure some stuff and then you get your alerts there. Of course, we'll add logging, and then we add the tracing, and at the end we'll add the Rabbit and the queue. But with each step, we will see what we already gain and what benefit we have from the system, right? Okay. And like I said, if there are any problems or anything, it's a real workshop, so I can come to you, to your laptop, and visit you and see how it goes. And like I said, if you don't want to follow, you can also leave, it doesn't matter. You already have the workshop, so you can do it at home also if you want. But if you want to like to follow, I will do it together with you. So the two things that we need, we need more, but through Docker we will get those Docker images from the internet, but at least we will need some IDE, and I'm going to use Visual Studio Code, so you can get it from code.visualstudio.com, there you can download it. And to work with Docker, the easiest thing is just to install Docker Desktop. Now, if you have Visual Studio Code running, you will have something like this on your system. It's Visual Studio Code. And the other thing that you will have, if you have Docker installed, Docker Desktop installed, you can check if Docker is available on your system. So if you do that with Docker -- version, -- version, you can check if Docker is up and running and if it's installed in your system. I'll talk a little bit more. So you have to check that you have a running Docker environment. That would be amazing. So Docker -- version, and also if you do the same thing with .NET, it's also important that you have it installed. So if you do .NET -- version, you also get the .NET version back if it's installed. I currently have 7.0 installed. There is already an 8.0 release candidate available, but I didn't install it yet on my machine. Okay. So that are the two things that we at least need to get started. Okay. And now we just follow along on the workbook that file that I created. So for monitoring, like I said, in a production environment, you probably will have some microservices or some endpoints available that somebody can call through their software. Well, we are now going to create 2 API endpoints, so at least we have something that we can call, and we're going to try to add monitoring to that. Okay, so like something that you would normally do in a production environment. To get an API in .NET, it's easy. It's just one line of code, so it's very easy. So what I would suggest is you pick some folder in your on your hard drive and create a new directory into it. Let's call it workshop hotel. There you go. And if you go into that workshop hotel 1, typo. And we are in the root folder of that workshop hotel folder, and then we're going to create everything in there. Okay, so just have a folder somewhere on your hard drive, have a command prompt available, and then we can do everything that we need. All right. So the easiest thing is that you have your the markdown file side by side. You can just copy paste the lines of code that we are going to need. Okay. So the first thing that we are going to add is a web API. Well, if you have the .NET CLI available, so the command line interface, then you just use this line of code to create one. So .NET works with templates. It has several templates built in, and one of those templates is just a weather API. It will give you some random weather information, and if you use this setup, .NET View Web API, it will use that template. Okay, so you will have already a certain API available with some data, but we're going to change it, of course. But at least we'll have something set up that's already working. So if you press Enter, it will create your API and it will put it in the name that you gave it. Okay, so I gave my API the name catalog.api because we're going to have 2 APIs, a catalog and a basket API, so like an e-commerce microservices environment a little bit. And this will be the first one. All right. So just copy paste that first line, and it will scaffold your first web API. Okay. The thing to check is to see if this actually already works, because Like I said, you needed to install .NET, so if you didn't do that up front or anything, it could be that the installation didn't work, so we need to try this. Well, the best thing to do is, because we installed Visual Studio Code, is actually go into that directory that we just created, and you can also already see I have my terminal environment set up that if it's .NET, it detects it and in which .NET version it is. But you can just press code dot, the minus R is not needed, but just code space dot, and it will open a Visual Studio Code with the folder in place. So that's very easy. So now you can see that it already created several things for you. It's not that important if you don't know .NET, but the most important part to remember is it will just make an API for you. Okay. So like if you do in the Java world, what's it called? I don't know actually. I saw that one during one of the demos, but I don't know what the name is for the Java. But okay, it doesn't matter. But in the .NET world, you will have endpoints, and those endpoints will be programmed in controllers. Okay, that's where they live. Okay, just bump it up a little bit more, that everybody can see. Okay, and the most important part now to do is to actually see if this program runs. So if you open the program.cs file, you should be able to actually start the program with the play button at the top. And we'll get our API available. But even the nice thing I find with .NET is that it will already auto-generate an open API definition of your API, so you already get a Swagger file available, and where you can even test your API and actually see that it does what it needs to be doing. So the API template that .NET supplies you, the Microsoft created, is, like I said, the weather API. It has one endpoint. It's a HTTP GET to get a weather forecast, and it will give you a JSON back with, I think, 5 temperatures for the 5 following days. But it's just random data, it doesn't matter, okay? But this is not what we want, okay? It's nice that it's already available there, but we're gonna change it, and it means a little bit more something like in the real world. I think that we'll have, like I said, a catalog API with products and a basket API that we can add cards in there to order stuff from our e-commerce. Okay, so we actually know that our API is running. I don't know if people are following, but if you are following, I hope you also get an API available. If not, it doesn't matter. Okay. No, it doesn't matter if you're not following. I hope it works, but it doesn't matter if you're not following. Okay, but like I said, so we currently have the weather forecast controller, and that's not what we want. We want to have a catalog API that generates products, so we're just going to delete both of those files, right? So we can just follow along. So we just delete those two. There we go, remove the trash. And then we're just going to follow the file again that we have available here. So what it says is that we need to create a new controller. Like I already mentioned with the weather one, so all the APIs have endpoints, and those endpoints are defined in .NET controllers. Well, I've pre-created a controller for you that you can just copy and paste. So we need a catalog controller, but at least you need to provide that file. So in the controllers folder, you add it. There you go. And then you have to just copy and paste all the code that's available here and put it inside that controller. There you go. Like I said, what we're going to do is we're going to return products, because weather forecast is not what we actually want. We want to have some products. So there will be, I think, 3 or 4 products in there with some information, and And the API will have two endpoints. So you can just go to items, then you get all the products, or you can go to items dash and then a specific ID, then you get one product, right? So the very basic API, just two endpoints, but at least it will be products instead of weather forecast, and it helps a little bit for the catalog API context. Now we have to do some extra preparation because in the .NET world, we want to work with objects instead of just pure JSON. So we'll need to add those objects if we want to do something with them. So we have to create some models. So in this case, like it states here, we have to create a models folder and we have to create some files in there. Okay? So that's what we're going to do. So in the root, you're going to create a new folder. We'll call it models. There you go. And in there, you're going to have a file that's called constants. Sorry for this is a little bit of boilerplate code that we need to add because otherwise the project will not work, but we'll come to the observability part a little bit later. So in the constants file, we add some constants that we're going to need. So in a production environment, you'll probably have some coarse policies available to not allow everyone to your APIs if you want to. I like to add them already to make it a little bit more production worthy. And the next thing that we're going to need is actually a product object. Like I said, we're not going to work with the JSON raw data. We want to use objects, so we're going to add the product object in our project. It will also be in the models folder, and we're going to call it product.cs file, and we're going to paste the product data, the product object in there. Right? Okay, so far so good. Like I said, if you're having a production API, you probably have some coarse policy. So that's cross-origin restrictions. So it's for site scripting programs to not allow them. So I already stuck an extension for that in the .NET world. You're going to use extensions to add those policies if you want to. So also this will be added to our project. So in the root folder, we're going to make an extensions folder, and inside that folder, you're going to make a course extensions file. And in that file, we're just going to copy paste the information that's available from the workshop. And the last thing to do, there is also a file called appsettings.json. It's actually, for .NET, it's a settings file where you can store things that you want to use during the setup of your API. So in this case, there's a certain, that's already been provided, there's a certain log level indication. In .NET, we have .NET logging already available from Microsoft, and you can use that with some arbitrary information if you want to. And also something about allowed hosts to get already some restrictions of your API. But this information is not correct for our workshop. We're going to change this, and you need to change this in what I provided here. So the only thing that we're actually going to add is the course setup. Right? But because we're not in a real production environment and we're not going to deploy our API yet, this information is actually not needed, but I like to add it already up front. So if you take this demo and want to convert it to a production-worthy API, you already have all the needed elements available. Okay? Because if you deploy your API, you have to change this endpoint, of course, because that will not be the production endpoint. Okay? So that's something you have to change when you want to deploy this API. Okay, the app settings are done. And then the last part is that we actually now need to extend our programs file with some extra information. And this is the first thing about our workshop. Like I told you, we want to have monitoring of our APIs, all right? But we can only monitor our API if we call it, okay? So there are other ways to do some logo monitoring also to see if it's been installed, to maybe look at Apache or Internet Information Service to see if the folder is there, that you can do. But then you don't know if your API is up and running, you only see that it's being deployed. So if you want to know if your API actually functions, the best way to do is to actually call it and to see if you get a response back. Well, that is normally something that you would do with a help endpoint. That's why they are there for. So in a production environment, I would suggest that everyone adds a certain help endpoint. So by default, this template doesn't have that, so we are going to add it, because if we don't have that help endpoint, we can't add our monitoring, because we don't have something that we can call, all right? So in the .NET environment, we're going to add a help point, and actually it's something that's automatically built in by Microsoft. You just need to reference some certain namespaces when they're here on top. But the best thing to do is just open the program.cs file, close the rest for the moment. Okay, and we're just going to change everything that's in the program.cs file with the code that's now available here. So let me just grab this. Alright, copy it, and just paste it. Okay. And what did I do now? Let me show you a little bit. I hope it's readable enough. We add some namespaces that are available with Microsoft. In the ASP.NET Core environment, there is the health checks, and also there's an extensions with health checks, and that gives you the capability to add a health endpoint. So it's up to you what you want with that endpoint. I'll typically map it to /health. So you can name that endpoint anything that you want, but in this case it will be health. And it will give you 3 possible responses. Or your system is just up and running, you get a 200 back, and then it will be healthy. You can also get a 200 back, but get a degraded text instead of a healthy text. I will explain that a little bit more later on. Or you can have a 500, and then it will be unhealthy, all right? Then it will actually not be correct. Something I didn't do in this demo, but something that you can do is you can extend your health checks with some dependencies. So, for instance, this is an API, it's the catalog API, and it needs products. Assuming that those products are defined in the database, then this API relies on the database. Okay, so it needs to have a connection to the database to get product information. And that could be a scenario. Maybe it's in Cosmos DB or it's in SQL DB, it doesn't matter. Probably it needs to gather that information from a database. Well, what you could do is extend this health checks and actually query the database to see if you get a response, to also do a health check to the database. If you add that to these health checks and the database doesn't respond, it's at that time you get the degraded information, meaning your service is up and running, but your dependency is missing. So that's why you get a degraded information, right? So healthy means I'm up and running and my dependencies are up and running. Degraded is I'm up and running, but some of my dependencies are not responding. And unhealthy means, sorry, I'm not available. Okay? Let's see, I don't think I missed anything. Maybe just double check. Yes, sir? I think we have everything. So, if everything went well, and we run this again, you'll now see we have a different view. We now have a totally different API. So we created a new API, so the weather API is gone, and now we have a catalog API with 2 endpoints, the items and the items/ID. So if I call the items endpoint now, try it out, execute it, you'll see that I get a 200 with a JSON array of 3 products, and those 3 products all have an ID. So if I grab one, the prod 001, and I go now to the items API and try it out, and I can put in an ID and execute it, and then we'll see that I get that product back. Okay, so our API is working, that's fine. And now the extra thing that you now can do to check if you did everything correctly is go to the help endpoint, because that's also something that we added. You don't see that in the Swagger definition because that's omitted, but it should be there because it should be there, but I should not be calling for the Swagger endpoint, of course. It's on the root of our API. And as you can see, our system is healthy because I didn't define any dependencies and our API is just up and running. So of course, it will be healthy. But our /help point, okay, sorry for that, it's a little bit small, but our /help point is available. One thing to note, if you do this workshop again at your own pace at home, it's stated in the workshop file too, but something you need to take care of each time that you start your APIs. What you will see is that .NET will generate new port numbers for each API. Okay, so you have to take note of them because we're going to add those in our configuration files later on to do the monitoring. So just look at what the endpoint is. In this case, it's 5078, and note it down, and then you can use it. Right? Normally there will be two endpoints. There will be a HTTPS and an HTTP one. So I'm not sure which one this is. Let me check. Yeah, this is the HTTP one. And that's good. We're going to use the HTTP one and not the HTTPS one. Why? Because we're working on a local system. And if we're working on a local system and we're now going to use Docker to connect to those APIs running locally, we don't have any certificates installed and we will not get a good connection. So if you do everything locally, just use the HTTP ones, it's not a problem, but in the production version, you probably will be using the HTTPS ones, of course. All right. So that's our first API. Like I said, we're going to create a second one, but because the first one will call the second one, and that's nice, because then later on in our visualization, we'll have a nice trace, one API called. So we're going to do this ceremony again, but now create a secondary API. Sorry for that, that's just a little bit of the setup for the APIs, but all the other things will be more interesting, because then we'll do the observability, of course. So the second thing that you need to do, first we did the catalog one, and now we're going to do the, let's see what the name was, the basket one. So we first did the .NET View catalog API, and the second thing is we're now going to do the .NET View basket API. So same thing, you're just going to go to the root of your directory, and the new folder that you created, workshop hotel, I created it. I'm going to paste again the .NET View setup, and now it's going to create again a weather API, but now it's going to be called basket API. Okay, it's not going to be called weather API because you named it specifically, but it will use the same weather template. Okay, now we're going to go to that basket API folder. Okay, and we're going to open code again. If you use Visual Studio Code and you do code space dot, it will open a new instance of Visual Studio Code with everything from that folder opened. If you do -R, if you already have a Visual Studio Code open, it will replace what's open there and open this one there. So you only keep one Visual Studio Code open, but it will replace, like you see now, my catalog API is gone and my basket API is open, but it kept one instance of Visual Studio Code. So the -R is just a grow if you want to quickly switch. All right. But again, here you will see we have a weather forecast controller and a weather forecast file. Again, you can just drop those, delete, move the trash, and then we're going to go to the workshop again and see what we need to add. Let's see, there was a catalog. Let's look at the catalog. Catalog API with the health endpoints, and now the basket API. Okay, similar setup. We're going to create a new controller, like I said, that's where the definition of our endpoints are, and we're going to call it the basket controller, and we're going to put it in a controllers folder. Controllers folder was already there, So we just need to add the basket controller file, and we can copy paste it what I put here. Now the difference here is that the basket controller, so the difference here is that the basket controller will have an endpoint, but it will be a post. So we're going to push data, and the catalog API has to get endpoints, so we're going to retrieve data. So that's the difference. And as you can see later on, this basket API will call the catalog API, so that we do a hop in our distributed software system. We go from one API to the other. That's the whole idea of why we want to create two APIs, so that at least at the end we have our observability and our trace over different APIs. Okay? So it just has one HTTP post endpoint. We already set that up, but to actually make it work, we need to also add again some models, because in .NET it's an object-oriented language, so we need models to work with our data. Okay, I'm already going to copy it, but you need to have a models folder and a basket item file in there. Okay, so in the root, I'm going to add a folder called it models. I'm going to add a file, and then it's called basket item. And there we go. We now have a basket item available. Okay. Then we also need to create a constants file. Constants. Then we're just going to copy paste what's in here. There we go. And of course, the basket can also contain products, so we also need that product file that we created first. So product products, yes. Okay, I'm just going to copy paste product information. There you go. Okay, that's all there. And then we are going to need to call the other API, and in .NET that we typically do something we call a service. So it's just an HTTP call, but you wrap it in some small method so that you can recall it if needed. So we're going to create a services folder. Services folder, and we're going to create a file called catalog service. That's yes. All right. Oh, sorry. And we're just going to copy paste again what's in here. But the only thing that it will do is it will use the HTTP client that you get available in .NET, and it will just call the other API. So, but what is important and not to miss if you do this again at home, like I said, I don't know what the port number will be that will be generated for your other API, so you have to fill in the correct port number everywhere when it states port number, because that's something that you need to do to make this happen, of course. But we'll fix that later on. And to work with such a service in .NET, we can use injection, dependency injection. And for that, we're going to need interface. So, like I said, I'm trying to make it a production-worthy API. So at least you will have some good understanding of what you need to do in .NET world. So we're going to create an interface iCatalog service also in the services folder, and it will have an interface available so we can dependency inject it when the program starts. Also, we need a course extension file. Yeah, nothing too fancy, it was already there to the other API. So in the root, I need the folder, extensions, okay, now we're going to call it course extensions.cs, and we're going to paste it with that. So it will add course main policy, like I said, don't worry about that too much, it's just something if you go to production that you need to take care of and learn and understand. And the last thing, again, is just change what the programs file does. So the programs.cs file, and just copy paste everything over it. And normally, I think if you didn't miss anything, I think, I see I made a typo in the file. There's a plus sign. I will amend that later on at the end, of course. This is something that you don't need. That's something missing. But if everything again went well and you press play, you at least now have a secondary API field. It has a post, and normally it should work and post to the other API, but like I said, I didn't put in the port number yet, so let me try to fix that. So the other one was running at 5078. So let me first fix that again. So go to the catalog service. Let's use the HTTP one. 5078. Okay. And run it again. All right. Okay. Now we have our positive API, and we can try it out. And what you need to do is you need to add the product ID in the body, and then it will call the other API with that ID to get that information from that API. And it's actually not working. And why? Because it's confused. Did I make a mistake? Which different want to do? Still running. Oh, did I stop it? Yeah. Okay, that's silly. I thought it was still up and running. Okay, so let me start up a new Visual Studio Code instance. All right, grab the catalog API, and let's start that one. Okay. Normally we should now have two APIs running. Yep, it's on the same port again. So let's try this again. And I will get back the 200 with the response body. So it's just to illustrate that it actually called the other API. It's nothing too fancy. And last thing is check if our health endpoint works, because that's what we added. It's there, it's healthy. But finally, sorry for this, there's a lot of boilerplate code, but that's how you make a .NET API. But now we at least have two APIs that we can call, so we can monitor them. And that's the first thing that we're going to add. So we're going to add Prometheus and Blackbox to actually call our endpoints and gather metrics. So that's the first thing about observability. We want to create metrics, and we want to create metrics on the endpoints that we have generated. To do this, we're going to use a Docker environment. So we're going to install Prometheus through Docker, and we're going to install Blackbox through Docker. Okay? The easiest thing to do this is just create a Docker compose file. So Docker minus compose with YAML file, also in a certain folder. Okay? What I like to do is what did we create? We create a root folder. And in that root folder, we have now two subfolders, the basket and the catalog API. So let's create a new one, and let's call it Docker. All right, and we go into that folder, okay, and now we can add again a new Visual Studio Code instance to that folder. So all the Docker configuration will be in that subdirectory, all right? So the first thing that we need to add is a Docker compose file. So let's add it, just Docker minus compose.yaml file. And all the extra tooling that we're going to use, so the Grafana, the Prometheus, and anything else, low-key tempo, will all be configured through this Docker compose file. So you just start it up, and it will start everything for you. The only thing that can happen if you try to do this now locally here, that maybe through the Wi-Fi, it's not that great. So maybe the Docker image just takes time to download. But if you do it at home with a good connection, everything will work smoothly. To actually work with Prometheus and let's see where I was. With Prometheus and Blackbox, well, Blackbox is just a small tool that will call endpoints. And you can call different endpoints. You can call gRPC endpoints, HTTP, HTTPS endpoints. It doesn't matter. You can call a lot of things, but you just have to tell it what to do. That's the only thing, all right? So you have to say which protocol you want to use. In our case, it will be HTTP. And then, together with Blackbox, you can tell it which endpoints you want to actually call, all right? So the first thing that we need to do is set up Blackbox, and the Blackbox configuration will be also in a Blackbox YAML file, okay? So again, we are in the root of our project, where the Docker environment was. That was this one. Let's make it a little bit bigger. And the first thing that we're now going to add is the copy-pasted it, the Blackbox configuration file. So the only thing that we need to configure is tell Blackbox which which protocol you're going to use to actually call the endpoints. Like I already said, if you just look up the Blackbox documentation, you can find everything about all the other possibilities, but in our case, it will just be HTTP. And you can also set the timeout so that if it didn't receive any response back within 5 seconds, it will tell it it was a failure instead of a success. Okay. So in our case, we're even going to use the ID4 protocol. You can set it to 6 if you want, and we're going to use get over HTTP. All right. So that's the only thing that you need to configure for Blackbox. And the second thing that you need to do is actually add Blackbox. So install it, and we're going to do this through a Docker image. So the Blackbox Docker image is available on Docker Hub, and the only thing that you actually need to do is copy paste this Blackbox setup in your Docker Compose file. So the Docker Compose file tells you what Docker image that you need to grab from the internet. It's going to be this one, the Blackbox exporter. I put the link in there also that you can, if you just press that one, you will see what the current release is, that you can update that version if you want to, or you put it to, you don't put the version, or you put the latest. Okay, you can do that too, but I don't like that because in a production environment, if you put latest and you do maybe by mistake reset of your Docker environment, it could be that you get newer versions. So I like to version my Docker Compose files, but then you always have to change them. I know. So potato, potato. Then we're going to say on which port the Blackbox exporter will run and which configuration file to use. It's the one that we just created. All right? That's the only thing that we did so far. So if everything now works like we hope it does, let me clear the screen. You can see those two files are there. We can now use Docker Compose up -d, and we're going to start. And the only thing that it's going to do is going to start Blackbox. That's it. So, but that's not all that we want. We also need to tell which endpoints to query, and we can't do that with Blackbox alone. We need Prometheus for that. Okay, so let's stop this then. Docker Compose down. Okay, we stop it again. And now we're going to add the secondary element of our observability stack, and it will be Prometheus. For Prometheus, you also need a configuration, and this is also important. Again, like I told you, if you do this at home, everywhere you have to load the port numbers for your endpoints. Okay, so in that Docker Prometheus configuration file, there you're going to say, hey, I'm going to use Blackbox, and Blackbox is going to target those endpoints. Okay, so that's the whole idea of how this works. It's actually Prometheus telling Blackbox which endpoints it needs to monitor. Okay, so you need to know those two port numbers from the APIs that you created, and you have to change those to the actual numbers. And you can see we actually call those health endpoints that we created. Okay, and with that, it should actually get you metrics of your APIs. So the configuration will be done in a Prometheus.yaml file. So that will also just be in root, Prometheus.yaml. There you go. And we just copy paste this configuration file here. And like I said, we now need to actually know both port numbers. So the first one was 5078, I guess. And the other one was something with 5111. Let me check. So 5111. Okay, that's easy. 5111. The notation is maybe a little bit strange. In a production environment, you will just have your open URL, but because we're now all doing everything locally, so two APIs running locally on the host of our Docker environment, you can do something like this, host.docker.internal, then it jumps out of your Docker sandbox and calls the host itself. So it's the Mac that I'm running in, and it's just going to use those two endpoints. Okay, so that's the Prometheus configuration, but of course we also need to install Prometheus, and we're going to install that through Docker. So again, we need to go to our Docker Compose file and just extend it with Prometheus. normally, yeah, no problem.
Do you need to do that for any endpoint that you have in your application?
Yes.
So every time you do a new application,
You need to have an Ethernet in there, yeah. But it's a configuration file, so normally you can auto-generate it with some tools or anything for that. But you have to somewhere configure what your endpoints are. Yeah. There are other tools that make this better, but then you have to do another setup of your software environment. So in the Microsoft stack, there is now something called Dapper. I don't know if somebody knows that. So that's a system that's a little bit on top of your microservices, and then it has automatic endpoint detection, and then it will generate that all automatically for you. But then you have to use some extra tooling, because we're now doing everything manually, yet we have to have a config file with all the endpoints and everything. So that's Prometheus, sorry, it's the other way around. And now we have to add Prometheus, of course. And again, it's just grabbing some Docker image from the internet, putting it in our Docker compose file. There you go. And I think we also need to add a volumes element for this, because Prometheus also stores local data in Docker. So we just need to add that too. I don't know how familiar you guys are with Docker, but let me just again tell you a little bit on what I did here. We just grab again a Prometheus image from Docker Hub to download it. Again, I added the releases element, so you can also check if it's still the same version. Could be that today it's already 2.48, I don't know. Maybe somebody can check already. It will be on port 9090, and like I said, we are going to use a configuration file again. It will be the Prometheus one that we just created. And something nice in Docker, you can say this Docker instance needs to wait on this other instance. So you'll see, if you spin this up, Blackbox first needs to be available before the Prometheus instance will be available. Okay, so it's something from Docker that you can make dependencies on different Docker services in your Docker compose file. All right, and with that, normally, if we now do it again, Docker compose up -d, we'll now have two things running. We'll now have Prometheus and Blackbox. You will see that this goes very fast, and that's because I already have the Docker images on my local machine, so that's why for you guys probably will take longer if it's the first time. If you will now want to see if these things are actually online, well, then you can use the Docker desktop tools, the dashboards, to see if the things are available and up and running. So you see, I have the Prometheus and the Blackbox are running, but I like to use another tool for that, and it's called Portainer. I don't know if somebody of you use that. It's an amazing tool. It's also free, and it gives you a little bit more of a visual representation of what's actually up and running. And the nice thing of Portainer is that it will also expose those ports, and you can just click and open the website straight away. So for me, if we actually want to see the Prometheus endpoint or the Blackbox endpoint, you just can click it, and then you see that it's available. And already you can now see, because I just kept my two APIs up and running, you will now see that our Blackbox is probing. I think I set it on 10 seconds or something like that, or 5 seconds. I don't know. That was in the Prometheus config file. I missed that with the explanation. Excuse me for that. But you will already see that it started calling our endpoints, and they are available. So we had a success. So if I now stop those endpoints, I will have a failure or unhealthy, and it will show up in my monitoring as an unhealthy. So you will already see, and if I just wait and refresh, the list will be longer and longer and longer, because it will just add every 5 seconds. I think I added it. Let's double check. Prometheus. Yeah, do a scrape interval of 5 seconds. So it will get each 5 seconds data from Blackbox to get the endpoints information. So it's already working, but now we don't have a nice visual representation, all right? And like I said, we want to do this with Grafana, so the last thing that we need to do is actually spin up our Grafana environment. Again, it's always the same setup. Again, we just need a Docker file, and we're gonna install that. So let's see. So we have the black box, but you can also check if it's working inside Prometheus if you want to. So let's see that. That's nice. So if I start up Prometheus, I can see if there is a probe success. Execute, and then you will see that yes, indeed, for the two health endpoints, we have a success rate of 1 instead of 0. 0 means that it was a failure, but 1 means yeah, the services are up and running. So, but then you need to understand Prometheus, or you need to understand Blackbox. That's not nice. We want to have a nice dashboard, so we will go with Grafana. All right. So to install the Grafana, we need to do something more than that. I already provisioned the dashboard that's nice for this environment. Okay, it's a long JSON file, so that's the only annoying part of this. But what you can do is go to my the link that I sent you, my other GitHub page, and there you can just download that YAML file if you the JSON file if you want to. That's maybe much easier than copy paste it from the Markdown file. But yeah, it's up to you what you do. But Grafana works like this. You can set up a Grafana environment and you can create dashboards. If you want to, if you have dashboards pre-created, you can provision them in a provisioning folder. And then as soon as Grafana starts up, it will look in that folder, and everything that's available there, it will automatically be available in your Grafana instance. So for us, that will be that we will create a dashboard for our Prometheus monitoring, and that will be already available for us. And also, we're going to have some alerts and data sources later on. I have to look at the time to see how far we can go. Yeah, we'll try it. So if I want to have this dashboard pre-provisioned when I install my Grafana instance, I just have to download that file, put it in the correct folder, and then Grafana will pick it up. Okay, so in this case, it will be in a provisioning subfolder for Grafana. So let's add that. Let me see in which directory I am. Okay, in the root of our cover. So let's add a new folder. Let's call it Grafana. All right, and let's make a provisioning folder inside the cover. Okay. Need to do it step by step, of course. Grafana. Okay, make provisioning. Let's see if I spell it correctly. Okay, and let's make a extra folder inside of it. Dashboards. All right. Okay, now we have everything available. If you now refresh, yeah, you will see this is now available in our Visual Studio Code. And so in the dashboards folder, we have to put two files, a dashboards YAML file saying, hey, Grafana, look in this folder for all the dashboards that I want, so a little bit of the configuration, and then of course all the dashboards that we have provisioned, and that's this file. So I'm just gonna try to copy paste them because I have them already on disk, or for you guys, if you want to do this at home, it's also available on the Markdown file. So this is the Prometheus Blackbox dashboard JSON file, and this is the dashboards.yaml file. I'll copy paste that because that's not big. I will add that. So dashboards.yaml file. Alright, copy paste. So it will be in the Grafana provisioning dashboards folder. That's going to look. So that's in this folder that we are. And we first now need to add the other one. Right, I'm going to try to copy paste it, of course. So let's see. Projects. Look at available something else. Here. Provisioning dashboards. Let's copy that. Here. So that's something, if you're not familiar with Grafana, it just tells Grafana, hey, when you start up, look for this folder, look for all the JSON files that are in there, and create dashboards based on those JSON files. Okay, and we already have one created for Prometheus with Blackbox. Now, the last thing that we need to do is actually set up Grafana, and Grafana again. It's through a Docker file, and this is it. Okay. So we open our Docker Compose file again, and above the volumes, we'll add the Grafana one. Also here, a little thing to note, just to make it easy for you to run this at home, I disabled the login page of Grafana. That's something that you can do, but it's not something that you want to do in production, all right? So keep in mind of that. So if we start with Grafana now, it will not prompt you for a login. It will just automatically log you in as an admin. But like I said, it's not something that you want to do in production. In production, there is a possibility to hook this up with Active Directory if you want to, that you automatically, the people of your company can work with them. So there are a lot of options available there. And then again, I will tell it to look for a provisioning folder because that's how it knows that there are provisioned files there. Okay? It will be available on port 3001, and it's dependent on Prometheus. I think we need to add something extra. I also will add the Prometheus data source in Grafana also, so that you can look at the data of Prometheus straight away in Grafana also if you want to. And this is done through data source provisioning. So also for that, we'll create a file. It's called datasources.yaml file, and it will be in the provisioning folder also, but again in a subfolder called data sources. So the other one was dashboards. It's going to be data sources, and in there, there's going to be a file called data sources.yaml, and we'll paste in the information that we provided here. And this is something very neat because we are working in a Docker environment. The URL to point to your Prometheus is just called Prometheus 1990. So that's the name of the service that I put in my Docker Compose file. If you use a Docker Compose file, you create services, and each service is based on a Docker image. Those services, the name that you provide, is also automatically the URL that you can use inside of your Docker environment. So that's the way that you can call several Docker services through each other. So that's the name I gave to that service. Let's check it again. So you can see the service itself is called Prometheus, and that's why we can just call that URL through another Docker service. So let's save everything. Okay, let's double check the files. So we did the dashboards, we did the data sources, we did Grafana. Grafana itself also stores data, so we need to add a volume in our Docker environment also. So let's do that also. And there we go. And normally, okay. Right, Docker Compose down because I think everything is still running. Yep, and then we can do Docker Compose up again. And I will have a Grafana instance extra besides our black box and our Prometheus. If now we go back to our container environment, you can now see that Grafana is also up and running. And if we open this now, you will see that we are now in the Grafana environment. So the Grafana itself is something you can follow courses for this for a whole week if you want to. So it has a lot of options, and one of the main options is beautiful dashboarding. But in the end, it can also represent logs and metrics and stuff like that. But for us, we now should have a Prometheus black box dashboard available. And the beauty of it, sorry for that, I'm going to make it a little bit smaller, but it's nicer if it's all visible. And this is actually something that you would put up in an environment, in a production environment for some infrastructure people to follow. So now you have actual information of each HTTP service or microservice or whatever that you have up and running, because it's auto-monitored now by Blackbox through Prometheus. Prometheus is storing all the metrics data, and it's now pushed to Grafana so we can visualize it. Even so, if it would be a production-worthy API with a SSL certificate, you can also monitor when the expiration date is. And the whole benefit of using a Grafana environment is because it has built-in alerts capabilities. You can put alerts also on the certification failures. When they, a few days before that, somebody gets an email, hey, remind to update the certificate, because that's something that most companies sometimes forget to review their certificate. Another thing that you can do is also add alerts on the fact that your API goes down. So if it's getting 400s or 500s, that you can do alerting on that. And also for that, in the workshop, I also provisioned that alert, so it's already there. The only thing that you need to do, Grafana can create alerts, but you need to hook it up to something. It could be a Slack endpoint, it could be PagerDuty, or how is it called, to send SMSs. So you need to do two things. You need to set up the alert. I provisioned that for you guys, so it will see if you don't get 200s on the APIs. But the second part is something that you need to see.
It should be configured for any group.
It can be configured for a group, yes indeed. Yeah, but the configuration for that is not in the workshop, that's what I'm saying.
Well, it's in Grafana, right?
It's in Grafana, yes, but if you if you use Slack, for instance, then you need to provide a webhook URL. So that's something I can't give you. You have to see your Slack environment, what that webhook URL is, and paste it in. You can also do Teams connection and post in a certain team channel if you want to.
Azure.
Or to Azure Apps Insights and then there, do something there. That's also possible. Yes, indeed. So that's the. Sorry for it. I know it's a long workshop and we only have an half an hour, but that's the first thing of our observability environment. We have APIs and we have monitoring and we have done everything with Docker images to with Grafana. So, but that was not everything that we wanted. We wanted to have tracing. Okay, and to get tracing, maybe one more thing is that also, like I told you, Grafana can have dashboarding, but you can also look at the raw data, and the raw data is through the explore element. And in that explore element, we'll have all the data sources that you configured. Like I said, we now only configured the Prometheus data source, so that will be in our dropdown. Only Prometheus will be there because I provisioned it. But you can query that data also straight away in Grafana itself. You don't have to go to Prometheus if you want to, you can do that in Grafana. Back to our story. So now we at least have some monitoring available and everything is working. I will skip the alerting because that's not that fancy. But of course, the fancy thing that you will want is maybe you want to have logging or maybe you want to have tracing available. So also for the logging, seeing what the time it is, maybe it's nicer that I just show you a working environment and then explain you what I added, because this is again a lot of code to cover, but I will guide you through a little bit. So what we are now going to do, and this is the first thing that we're going to do with OpenTelemetry. So depending on which tech stack you are, you probably will have some framework that does the logging for you. If you are in a .NET environment, one of the most popular is called Serilog. It's also a framework that handles the logging for you. It will generate logs in a certain format that are easy to interpret and to read. So I chose that one because 99% of the .NET programs will use that one. But the nice thing now is that as soon as you use Serilog, you can now hook that up with OpenTelemetry. And instead of writing your logs to disk or to anything else, to a database or something, you now just push your log files to OpenTelemetry. And in our case, that will be an OpenTelemetry collector somewhere central, okay? And it's up to the OpenTelemetry collector then to decide what will I do with those log files. And it can send it then again to maybe to Azure or somewhere else. In our case, we will push that to Loki because that's our log database as a fact. So that's our log aggregator, okay? So what we did here now is that we just extended the API and telling it, you know what? As soon as you log some information, use Serilog, but write the logs not to disk or to a database straight away, but write it to OpenTelemetry. Okay? And like I told you, a lot of big companies went with the OpenTelemetry protocol, so Serialog understands OpenTelemetry straight out of the box. Okay. For that to do, but let me skip the code-wise, I can show you that later on. But again, what you can add as extra is now you need to add your OpenTelemetry collector. And how do you do this? Well, the OpenTelemetry collector itself also needs a configuration. And maybe now the image is more clear. In the OpenTelemetry configuration, you need to specify all the incoming elements, all the processing elements, and all the outgoing elements. And we'll, like the image that I showed you, they are called receivers, that are the incoming endpoints. I don't have any processors in this point, but then we also have the exporters, the going out routes. So in this case, we'll just have an OpenTelemetry collector that can receive data through gRPC and HTTP, and we have one exporter going to a Loki endpoint. So that means that we also need to set up a Loki Docker instance. And the part beneath is gluing the two endpoints together. So you're gonna tell it, hey, OpenTelemetry, I want you, when logs come in, I want you to use this incoming endpoint, and you want you to use that outgoing endpoint. So in this case, I'm telling it, OpenTelemetry collector, you're gonna receive logs in the OTLP format and export them to Loki. That's the only thing that I'm not telling you to do. Okay? So we need to create that configuration file. So let me already copy paste this because we need this. And for that, again, in the root of our Docker environment, we're gonna create the OTel.yaml file. So that's our configuration file for OpenTelemetry. And it currently has one input and one export, receive and export, and we link those two together. So that's that. And also, of course, we need to install the OpenTelemetry collector itself. So for this, it will be this baby. That's again in the Docker Compose. Underneath the Grafana, we can add the OpenTelemetry collector. The OpenTelemetry collector has several ports available, but the port for us that's important is this one, 4317. Because that's the one where you can send data to in a gRPC format, as long as it is in the OTLP protocol format on top of gRPC. And if you did look carefully, I will show you again. But did we stay here? Stay here, 4317. So that's the way we tell ASP.NET, our API, to push all the logs to our OpenTelemetry collector in the gRPC protocol, but the OTLP protocol. So it's based on gRPC to send it, but it's in an OTLP protocol format. So that's that. Did I miss something? No, I don't think so. Of course, we also need Loki, because Loki will be our log aggregator. Loki also needs a configuration file. For everything that we need to install, we need a configuration file. So okay, no worries, we'll create one again. It will be loki.yaml. All right, and we just copy paste what's available here. For Loki, because it's a log aggregator, you can tell it how to store the log files and how long to store the log files, and that you specify in the configuration. So in our case, it will be on disk with a rolling files. You know what rolling files are? They are based on a number, and they're going to be a period of 24 hours, and then it will create a new file and stuff like that. So it's just on disk that we're going to do this. And Loki itself will listen to port 3100, and that was what we configured in the OpenTelemetry collector. See? This is what we set as the exporter for the OpenTelemetry collector. And with that, we also, of course, need to install Loki itself. So again, a Docker image, Loki. And again, same setup. It has a certain port number, it has a certain configuration file, it stores data locally, so I need to add the volume again. But again, it's just an extra added image and an extra added Docker file. So we need to add logi to the volumes because it needs data on disk. There you go. And we can now say to Grafana, hey Grafana, I want you to wait not only on Prometheus, but also wait on Loki. To be sure that only Grafana will start if those other two are started. Okay. Did I miss anything? Yeah, like I said, because also in Grafana you can look at the raw data if you want to from all the data sources. So for Loki, because that's our log aggregator, we want to add that data source also. The first one we had was Prometheus. So we're now going to add Loki also as our data, one of the data sources Grafana can look at as raw data. Okay. And I think we have everything set up now. Okay, let's start our environment. So Docker compose down, because they were still running, I think. Yep, and Docker compose up. Oh, it seems I didn't have the OpenTelemetry connector. Good. And it fails, of course, because it's a demo, and demos always fail. Let me see which images I still have available on my disk. So that's also something nice. So I can check which, well, it has the 080. Which one did I add? So let's use the 01 because I already have that one available. Let's see. And let me just start. So probably something with the Wi-Fi or anything here, I don't know why. Yeah. So now we already have a bunch of things up and running, and it's a lot, sorry for that. But normally everything should be up and running and working. The only thing that I now am maybe out of time a little bit is to change the application to actually use that. But let's try it anyway. Let's see how far we can get. So to actually have this working, we need to extend our APIs to actually do logging. Okay, so that's the whole point of actually doing something. So to actually work with log files, you have to add a bunch of data in them. Okay, but maybe I prepared this demo up front, so maybe if I start the other ones, that would be easier. So let me kill the other ones. Okay, let's stop other Visual Studio codes. Quit. And yeah, I don't think I have any Visual Studio codes up and running, so let's see if I can start the other ones, and then I can show you that way. So I already prepared this demo. So try to take the basket API. There you go. And I run this one. Let's rebuild, see how it goes. Builds. Start your instance. Okay, so the basket API is running. All right. Let's start a new window. And let's open the catalog API. Rebuild. That one works. And then restore the instance. both up and running. Okay, they're now all up and running. We can go back to our container environment, and let's see. So we have a Docker environment. So now a lot of information is already there, and we have now Grafana. If you go to Grafana, yeah, we make it smaller, of course, but still our dashboard is available. But I just wanted to show you this because I now started up 2 new APIs. Those numbers are wrong, and now you see my dashboard that actually works because those endpoints are no longer on those ports, so they're wrong. So now they are stating that they are down. They're actually running. I need to change those, but it doesn't matter because we're not interested anymore in the monitoring. We're interested in actually in the logging. So if I now go to our explore mode, so looking at the raw data, you will now see that we now have an extra instance, Loki, because Loki was now configured through our Docker environment. So now we can use Loki to actually look to our log files that are available. And of course, I wanted to do something fancy and try this without changing the port numbers, of course, but now it's no longer working. But it's not because Prometheus is no longer calling the correct APIs. So this is going to be annoying. So let's do Docker compose down, let me switch. Like I said, I already prepared this, so if I just switch and just use this environment, it should normally work. Okay, so Docker compose SD. And hopefully this one will have all the correct endpoints available. And there we go. So I just switched to my previous prepared demo. So the 2 APIs are up and running, and because we are still constantly hitting those health endpoints with our black box information, also our .NET APIs will generate logs because the endpoints get called and it will automatically generate logs because it's all done with auto instrumentation. And those log files are now just available inside our query, inside our Grafana environment. So we have now the raw data of all the log files. And these log files are now in a JSON format with specific naming and specific values. And why did we get this? That's because we are using Serilog. Serilog does automatically create a whole bunch of ASP.NET API information. It will have status code, it will have how long the API took to require a response. It will also, because we are now injecting OpenTelemetry, tell you some OpenTelemetry information on how it's being used. And it will have the service name and stuff like that. So all the log info is now being pushed through OpenTelemetry to our Loki environment. And something that I already added here, but we didn't set it up yet. All our log files, because we now are using OpenTelemetry inside of our .NET APIs, I just added some configuration, we'll now already have a trace and a span ID. You remember the complete beginning of our presentation that I told you? The first response that gets into your environment will get a root span. It will have a trace ID as the root, and each single endpoint, in our case each single API, will have a span ID, meaning that's the API being called at this moment, at that endpoint, okay? For each trace ID, that will be a new number, but it knows that it was that API. It's the link between the API and the endpoint and the trace itself. So if we now call one API and it will call another API, it will be this information that OpenTelemetry will automatically for you pass along, all right? Meaning that you get the distributed trace automatically. To now visually see this distributed trace, we only need one more element in our environmental stack, and that will be tempo, because tempo will be the one that collects all the trace information and it will make this visible. Okay? okay, we don't still have a visual representation, we at least have the numbers already, but we can't see it yet.
Trace is generated by
OpenTelemetry. Yeah, it does that for you. So that actually the SDK that you added to your ASP.NET file, but like I said, there's an SDK for almost each tech stack, and that will do this for you. Yeah. So if you use not a Spring Boot, that was the name I was looking. If you have a Spring Boot Java API, also for that you can just inject OpenTelemetry, and it will generate those traces like this for you. So the last thing that we need to do is actually add tempo, but like I said, I already now have a complete environment what we're running with everything in it, so let me just show you. That's easier because we are a little bit out of time. Sorry for that. I thought 3 hours would be enough, but it seems not. So let me go to the code. Let me open a new Visual Studio code. That's easier to show you. Okay, let's open the folder, complete folder. Okay, so to add tempo, tempo is the database for all your tracing information. You also need a configuration file. It's always the same setup, right? It's just again the configuration file where you say some stuff. And in this case, you have to tell it where to listen and which protocol to use. Okay. And some extra information on how long you want to keep your traces. That's something also important if you do this at home. Because of keeping my laptop small in disk size, I've put the traces on 1 hour, meaning if you look in Grafana at the raw data of your traces, like we looked at the logs with Loki and at the Prometheus with the Prometheus data source, you can also later on look at the tempo data. It will only be kept for 1 hour and then automatically cleaned from your disk. Okay, so something in a production environment, you will probably want to change this. Okay, so something like maybe a week, that you keep your traces for a week and then discard them. I don't know. So it's all up to you in your environment. But I also see a lot of companies do is set this not too big, like on a production machine, set this to 48 hours, like 2 days, but have a secondary system to get those traces again out of tempo and store them on longer running disks to keep them offline. So if you want to look at them again later on, just take them from there instead of from the tempo environment itself. Okay. All right. So the configuration file, and then in your Docker Compose file, again you add an extra element, and it's going to be tempo in this case, and again a certain tempo version. You're going to tell it to use the configuration file that we just set up, and it's going to have certain ports to listen to. And it's going to depend, in this case, on the OpenTelemetry connector, because it will gather the traces from the OpenTelemetry connector itself. All right, and with that all in place, normally, like I said, this was already up and running, so normally if I go back to my website, which one was it? Let's refresh. See, tempo was already in there because this was the complete up and running version. So the traces are already in there. But the neat thing that I did now is I already linked the logs to the tempo. So that means that if I open a log file and I press here, that I now will get the trace information of that element. But because we are now just calling only the health endpoints, we didn't do the complete hop. So now I need to actually call one myself. So let's see. So now I need to know which ports it are, 5062 and 5177. So let me try this one. Localhost 551. This was it, right? 5177. Okay, that's the one. Let me stop the pages and white box, because otherwise we get those health checks constantly. Okay. All right, but what I did now in the complete demo, if you call one of those endpoints straight away, I think it was prod 001, I think, and execute it, then it actually calls the other API. It will put a message on the message queue, and then the message queue will pick it up again and work with it. So if you now look at our information, it should normally have everything in there. This seems tedious, but that's only because I didn't create a dashboard for these raw data, but you can also work with the raw data if you want. But you will see that we now did a post on the basket API, and if everything is now correctly set up. No, the message queue is still not in there, but okay, just
Sorry.
to complete. Yeah.
How does the trace ID carry over from?
OpenTelemetry does everything for you. Because we added OpenTelemetry as a protocol to each API, and also normally to the message queue, but this one is set up this intelligent, it will automatically be done for you. So that's the whole idea of adding OpenTelemetry. You don't have to worry about it. And if you do it everywhere, you will get that benefit that everybody understands where it goes to and where it came from. So now you can actually, you only have one log line from one team, and you already see that it went to the catalog API and came back. So the other way around can also happen, that you get a log line from the catalog to people, so we can try to search for that on you. And normally, you should have the same benefit that you can trace it back, and it went to the basket API also. So this was the basket endpoint. So if we now try to look for the log line in the catalog, so this was the log line from the catalog. So in a production environment, maybe the team from the catalog microservices has found an error. It will go to the log line. It only has this information telling us, yeah, this API endpoint was called, and it doesn't know anything else. But it has a trace ID. So if they now open that trace file, they can now see, oh yeah, it came from that call in the catalog API. So, no, in the basket API, right? It was that post with that data, because also here you will have again a span ID, and with that span ID again you can look in your logs, and you have the log line from which request generated that element in the other API. So at that point, you can hop over as many APIs as you want, and even normally, like I said in the workshop, you also have a distributed messaging system, even over distributed messaging system, and you will have a complete visual representation of how long it took, what it did, and what the payloads were.
Will it add the ID to the header?
Yes, actually underneath. Yeah. Yes.
The response to the problem.
Yes, indeed. Yeah. And so why does this all work? Because underneath there's actually a W3C. So that's the government body of all the HTTP protocol itself. And in there is a little set that's called trace information, and it's only using that actually. So it's because it's baked into the HTTP protocol that we now can leverage this. And OpenTelemetry just sets all the needed information and passes it along. Right.
So on the code, we just replaced the usual calling to.
Actually, we didn't really replace it because it was still Serialog, but we now pushed it to OpenTelemetry.
Imagine you have a Spring application with log project.
Okay.
You
Then
either replace in the code or you have some better.
you just have to see if that was something that I wanted to show also. And then you have to first have to see on the OpenTelemetry environment. So OpenTelemetry has a GitHub page and also some documentation. If maybe for your tech stack there is already an automated instrumentation available. Yeah. So and like I said, you have the two levels, or it's automated instrumentation, like I did. I only did configuration and everything worked. If it's not automated but manual, it also means that in each method, if you want to have a log line, you have to also do some extra information. But that's the only thing that you need. But then you actually need to touch your code. So it depends a little bit on how mature your tech stack is, but yeah, it has a lot of versions. And if you click on that one, you normally will be going to a certain repository on the OpenTelemetry environment, and then you can see for each instrumentation, there is one for C++, for .NET, and so all the repos are just online, and even if it's not in here, there are certain companies that are also adopting OpenTelemetry, but it isn't available in the OpenTelemetry GitHub repo, but in their own. So even there, it could be that it's not on the documentation page, but you can still use OpenTelemetry if you want, depending on the company that's behind. Because I don't know if you guys know this, but Progress, that's a 4GL database language, I don't know if you know that. They also adopted it, but it's not yet here on the OpenTelemetry pages. So, but it could be that the company already provides a certain OpenTelemetry framework for you.
If you have no way of like adding the instrumentation on the code itself, can you like read syslog or something like that? Or
It's going to be difficult because the whole promise of this talk is that at a certain point you have to generate your first span and trace ID. Otherwise, you won't have any clue of what things did or how they work together. Okay, so if you can't add instrumentation, you don't have any information. So that's the only downfall. But the good thing is that you don't have to do much if it's up to an automated instrumentation level. Then you only have to add the configuration. Of course, that's a change in the code and a deployment. I understand that, but it's minimal. It's not on your functionality. I didn't touch any of the controllers or the APIs or anything like that. I just changed the program setup that at the start of my API did some extra logic, but that's all. Normally, everything from your other things, from your API perspective, should still run, okay? And the other benefit, of course, is that if you already have certain things in place, like Jaeger or whatever else, or like already Prometheus elements, you can still use an OpenTelemetry collector to gather more information and get dashboarding in your file. Maybe you don't have the end-to-end tracing, but at least you already start with something and get some information on there.
One thing I didn't understand about it, we have all the logs. So I remember we have 2 servers in this case.
Yeah.
We have 10. You get one log entry per service, or you get one log entry in any program.
So from the API perspective, each API generates their own entries. So you should have 10. But the thing I did, I added an extra configuration to tell the logging framework to not write it in log files separately, but push those 10 log entries in one element. Yeah. But you can even have both. It doesn't matter. So if you still
You can collect all the work.
yeah, you can collect it's just a view. This view I have here, this view on the site.
The question is, you have the view, but you have one log entry for each internal request.
For each request, yeah. So it's like this. What you see here are those 10 files mushed together. So each entry is a request, and it doesn't matter anymore if it's from that API or that API. If you want to have this again separated, that can also be true, but then you have to set up or write it into separate files or something. This is just one big log of everything. So I don't know if this is the best setup. But the nice thing is that if you do it this way, you can just jump from one thing to the other and then just have everything available in here.
I have a question.
No problem.
Is it possible to generate this ID, in the API gateway, can I generate this ID over there and pass it through build OpenTelemetry?
Yeah.
Yeah.
So yeah, because that's what I said. So the difference in the auto instrumentation and the manual instrumentation is in the manual instrumentation you have to call a line of generate ID or something like that. So, and then it's gone.
So
That's the thing that you need to
it's
do.
already there in the request,
And then it will be added, yeah. But as at least as you configure OpenTelemetry and you have an OpenTelemetry collector to pass it along, yeah. But if you're, the could be that C++ is not auto-instrumenting, then in each method, if you know each API is your first possible entry, you have to add the first line in there stating generate IDs or something, or something. It's a broad idea, I don't know the code behind it. Because you have to do then yourself the instrumentation start.
I was talking about the API gateway level. So, for example, with COM.
Oh, there. Oh, that's
Gateway.
level.
I can
Oh, that's
just
a
header. I can
good
create the.
Yeah, I understand what you.
I
understand what you.
And generate a specific way. And I want to have that relation all the way from the COM gateway.
That would be a nice thing to test out. I didn't try that.
That's what I'm.
Yeah, that's actually a good point. I think if all the APIs understand OpenTelemetry like they do, and the header is on there, they will assume that it was already the first request, and then just generate the rest. Yeah, it could be, but I didn't try that yet. And the funny thing is that no API gateway is on the configuration files yet, so I don't know if people are already in that sphere. We are using an API manager of Azure instead of Chrome, but I didn't try that yet. So that's a good point. Maybe we should. And then you can even keep it outside of your.
That's like the closest to end-to-end that you can.
Yeah, maybe. That's a good requirement. Okay, with that, it's 5 o'clock. I hope you learned a little bit, but like I said, it's nothing new. The slides again, like I said, there are 2 ways to do this on your own, or go through the workshop yourself. But if you like my voice and you want to see me talk again, you can go to my Pluralsight course, and there it's a little bit more in depth even, so you can follow that also. Okay. And if you have any questions, just ping me. I'm not saying I'm a total expert yet on OpenTelemetry, but at least I know some other people, and I can maybe pass you along to some other. Okay. And now we have a beer, right?